All right, welcome back. So if you've ever logged into a Linux machine and seen a desktop, with icons and windows, you've used a GUI. Simple enough, right? Well, for the LPIC-1 exam, just using it isn't going to cut it. You need to know what's actually happening underneath those icons. So today, we are going to decode the entire Linux graphical stack, from the shiny desktop you see all the way to the remote protocols you'll be using out in the field.
So here's our game plan. First, we'll nail down what a GUI even is. Then, we're going to look at the big players, the major desktop environments, so you can pick the right one for any situation. After that, we dive under the hood into the engine that runs it all, the X Windows system. Then, we'll get into remote access, and finally, we'll wrap it all up with a rapid-fire cheat sheet to make sure you crush those exam questions.
I mean, you've seen this a million times, right? A standard Ubuntu desktop, probably running GNOME. We click around on it every day. But as a Linux pro, you've got to see the layers. You have to understand the stack that makes this screen even possible. You've got the display server talking to the hardware, the window manager drawing the windows, and the desktop environment pulling it all together. And that is exactly what we're about to dissect.
Okay, let's start at square one, the absolute fundamentals. What exactly is a GUI, or as you'll hear it, a GUI, and how does it stack up against that powerful command line that Linux is so famous for? Look, the command line gives you raw, unfiltered power, for sure. But the GUI, well, it gives us an intuitive, visual way to get things done. And don't ever think it's just for new users. As a sysadmin, you will absolutely use GUI tools for critical jobs, like managing disk partitions with gparted or getting a deep look at network traffic with Wireshark. Knowing both isn't just a good idea, it's non-negotiable.
One of the best things about Linux is the sheer amount of choice you have. You are not locked into one single look and feel. So, let's check out the 3 big desktop environments that you absolutely have to know for the LPIC-1 exam.
First up, we've got GNOME. This is the default on some heavy hitters: Ubuntu, Fedora, Red Hat Enterprise Linux. It's really known for its modern, kind of minimalist interface called the GNOME shell. Now, instead of a classic start menu, it uses this activities overview to manage all your apps and workspaces. It takes a little getting used to, but once you do, it can be a super efficient workflow.
Next up is KDE Plasma. If you want a desktop that feels familiar the second you log in, this is probably it. But its real claim to fame? Customization. I mean, you can change everything. The panel layout, the widgets, which they call plasmoids, even the little window animations. This is for people who want their desktop to work exactly the way they want it to.
And finally, we have XFCE. Its whole reason for being is to be lightweight and fast. So if you're trying to breathe new life into an old laptop, or you need a snappy desktop for a server VM that won't gobble up all your RAM, XFCE is the absolute gold standard. It's all about performance over fancy visuals. So this table really puts it all in perspective, doesn't it? It's that classic trade-off. Do you want the polished, very opinionated workflow of GNOME, even if it uses more memory? Or maybe the infinite tweakability of KDE? Or just the raw speed and simplicity of XFCE? For your exam, you need to know these differences. Out in the real world, your choice is going to depend entirely on the hardware and the task at hand.
Okay, so we've seen the what, but now let's get into the how. How do these desktops actually put pixels on your screen? Well, to understand that, we've got to go one layer deeper, down to the foundational engine of pretty much every Linux GUI, the X Windows system. This diagram shows the stack perfectly. Just look at that bottom layer, the display server. This is the low-level piece of software that's actually talking to your graphics card. Now, sitting on top of that, you've got the window manager, which is in charge of drawing the window borders and title bars. Then, the desktop environment bundles all of that up, adds its own apps and panels, and gives you the complete package. For decades, the undisputed king of display servers in the Linux world has been the X Windows system, or X11. And get this, it was developed at MIT way back in the 1980s. Its age gives it this incredible stability and flexibility, but as we're about to see, it's also the reason why some newer alternatives are starting to pop up. Okay, this is the crucial part. X11 is built on a client-server model, and that's where its real power comes from. The X server is the program controlling your physical display, your screen, keyboard, and mouse. The X clients? Those are the applications, like Firefox or your terminal, that need the server to draw them. And here's where it gets really cool. Because of this model, the application, the X client, doesn't even have to be running on the same machine as your screen.
The display environment variable is what tells any application exactly which X server to draw its window on. This idea, this network transparency, it's a core feature of X11 that was baked in from day one.
Now, while the Xorg server has been the standard for, well, forever, the Linux world is shifting. The modern successor is Wayland. It's a newer protocol that was designed from the ground up to be simpler, more secure, and get rid of some of the old, clunky baggage from X11. Big distros like Fedora and Ubuntu are even shipping with Wayland by default now, so it's absolutely essential to know about it.
So that whole client-server model we just talked about, it opens up a massive topic: remote access. As a sysadmin, you will constantly need to manage graphical applications on servers from your own desk. So let's break down the protocols that make this magic happen.
For the LPIC-1, you need to have these 4 remote desktop protocols locked in. You can almost think of them in pairs. You've got XDMCP, which is the old-school native X11 way of doing things. Then VNC, the classic screen-sharing tool that works on pretty much anything. And then you have the modern high-performance options: SPICE, which is built for virtual machines, and RDP, which is Microsoft's protocol that you'll often be connecting to from your Linux machine.
This table is basically your cheat sheet for picking the right protocol. Now, the one thing I really want you to take away for VNC is security. By default, it is not encrypted. I'm going to say that again. Always, always tunnel your VNC traffic over an SSH connection in a real-world environment. RDP and SPICE are more modern, they're more efficient because they send drawing commands instead of just raw pictures of the screen, and they're secure right out of the box. And if you're doing any serious work with KVM virtual machines, SPICE is what you want.
But you know what? Sometimes you don't need a whole remote desktop. You just need to run one single graphical app from a server, like maybe a database management tool. For that, nothing beats the elegance of SSH with X11 forwarding. Just using that X flag tunnels only that one application's display back to you. It's lightweight, it's incredibly secure, and it's a command you will find yourself using all the time.
All right, let's bring it all home. We're going to consolidate everything into a quick hitter review. If you're studying for the exam, these are the facts you absolutely positively have to know.
Okay, let's run through the components one more time. In order. When you boot your machine, the very first thing you see is the Display Manager. That's your graphical login screen. Once you log in, that starts your desktop environment, which is the whole shebang: the panels, icons, wallpaper, everything. And running inside of that is a Window Manager, the specific process that's actually drawing and managing the application windows themselves.
And for the backend, you've got to lock these in. The display server is the foundation. Know the difference between the classic Xorg and the modern Wayland. You have to internalize the X11 client-server model. Memorize those 4 remote protocols: XDMCP, VNC, RDP, and SPICE. And finally, for secure single-app access, SSH-X is the command. You just got to know it.
So, the next time you log into a Linux desktop, I hope you won't just see icons and windows. You'll see the architecture humming away beneath it all. The servers, the clients, the protocols. Mastering this stuff isn't just about passing a test, it's about really understanding how Linux works from the inside out. And that, my friends, is a huge step on your journey to becoming a certified Linux professional.